is your educator Haripriya. Do not forget to like this video, share this video with at least one friend of yours. It can be a school friend or a family friend, or a community tuition friend, whoever. And also comment below and let me know what kind of videos do you want to watch on this channel, right? So let us get started with the topic rational numbers. Going to do in today's class. Check with the Wi-Fi. Okay. Wi-Fi looks perfect. Alright, so these are the 4 different properties that we will be taking care of right now. And alright, so starting off with closure property for addition of rational numbers. When you add 2 rational numbers, are you getting back a rational number or not? So whenever you take any 2 set of rational numbers, positive, negative, both negative, one positive, one negative, you will always end up getting a rational number. So in this case, you have 3 by 2, the addition and subtraction of rational numbers. We have already seen this in the first session where I spoke about operations on rational numbers. Alright, so here the LCM here would be 56. So I'll multiply the numerator and denominator here with 7 so that it becomes 56. I'll multiply the numerator and denominator with 8 so that the LCM becomes 56. So here you have 21 minus 40 plus 21 minus 40. So the answer is minus 19 by 56. Alright. So what happened in a closed group of only rational numbers, when you picked 2 rational numbers and when you added them, the answer is again a rational number. So you can say that rational numbers are closed under addition. Now, what about subtraction then? When you subtract 2 rational numbers, are you getting back a rational number? Yes. So, we are subtracting minus 5 by 7 minus 2 by 3. The funda is the same. You're going to take the LCM of the denominators. So, the LCM of 7 and 3 is 21. So, you multiply the numerator here with 3 and the denominator also with 3. Why? Because we want to make the denominators as 21 because that's the LCM. So here you have minus 15 and here you will multiply with 7. Minus 15 minus 14. So the answer is again minus 29 by 21, which is again a rational number. So what does closure property say? When you take 2 rational numbers and when you operate between them, when I subtract them, the answer is a rational number again. Yes, so rational numbers are closed under subtraction. Similarly, they are closed under multiplication also. Whenever I multiply 2 numbers, 2 rational numbers, I am getting back a rational number. Be it 2 positive rational numbers, 2 negative rational numbers, 1 positive, 1 negative rational numbers I am multiplying does not matter because the answer is always a rational number. Alright. Hi Kritishna. Welcome to the session, bacha. How are you? Yes, long time no see. Alright. Now let's talk about the division of, rational numbers. Actually, fun fact, when you divide any 2 rational numbers, you're always getting a rational number. But there is one exception, that is division by 0. When you divide a rational number, let's say minus 5 by 3, you're dividing by 0, the answer is not defined. You cannot say what the answer is. So, rational numbers are not closed under division because of this one exception, that is division by 0. Because of this one exception, we should say that rational numbers are not closed under division. If I remove this exception, then they are closed. You divide any 2 rational numbers, you will always get a rational number. But 0 is also a rational number, no? So that's why when I divide 2 rational numbers where one of them is 0 in the denominator, then it is not defined. Because of this one exception, we cannot say that it is closed. So that's why it is not closed under division. So the moral of the story is when it comes to closure property, whole numbers, addition and multiplication they follow. Integers, addition, subtraction and multiplication they follow. Rational numbers, addition, subtraction and multiplication are closed. Okay, rational numbers are closed under multiplication, addition and subtraction of rational numbers. As you can see, nobody here follows division. Like division is not closed for whole numbers, integers or for rational numbers. Alright. Now let's move forward with the next property, which is commutative property. Now what happens in commutative property? If I take two whole numbers, the order in which I add them actually should not matter. And whenever, if I take a plus b, b plus a, the answer has to be the same, right? So here I am taking my a to be minus 2 by 3 and b to be 5 by 7. So in the first case, I am adding a plus b. I am getting 1 by 21. How did I add? Same LCM method. Let me quickly show it to you here. Minus 2 by 3 plus 5 by 7. The LCM has to be 21. So you multiply this with 7, you get minus 14. Plus you multiply this with 3, you get plus 15. So it is 1 by 21. If I add 5 by 7 with minus 2 by 3, I am again going to get 1 by 21. So the order in which you add your rational numbers does not matter because the answer is going to be the same. Your a plus b is equal to b plus a. So addition is commutative for rational numbers. What about subtraction? It's not working. Your a minus b is not the same as b minus a. 2 by 3 minus 5 by 4 is not equal to 5 by 4 minus 2 by 3. Now I have taken my a as 2 by 3 and b as 5 by 4. So here I did a minus b. Here I did b minus a and they are not the same. For once I got minus 7 by 12. For the other I got plus 7 by 12. They are not the same, right? So subtraction is not commutative for rational numbers. Alright? It does not follow. And then multiplication, yes, it's a thumbs up again. If I take two rational numbers, I have taken a to be minus 7 by 3 and I have taken b to be 6 by 5. Here I have multiplied a and b, I got minus 14 by 5. Here I have multiplied b and a and I have got minus 14 by 5. The answer is the same. A multiplied with b equals to b multiplied with a. So multiplication is commutative for rational numbers. Addition is commutative. Multiplication is also commutative. But do you think division is commutative? No. For integers, whole numbers, rational numbers, division is never commutative. Subtraction is never commutative. So if I divide two integers or two rational numbers in any order, the answers are going to be different. When I divide, if I am taking my a to be minus 5 by 4 and b to be 3 by 7, a by b, remember the KCF rule, keep, change and flip. We have already spoken about this when we were talking about the operations of rational numbers. Hai na? So keep the first rational number as it is, minus 5 by 4. Change the division symbol to multiplication symbol and flip, matlab change, reciprocate. 3 by 7 will become 7 by 3. Then multiply the numerator with the numerator, denominator with the denominator. But when you see a by b is not equal to b by a, so division is not commutative for rational numbers. Alright. Division be like, yes. Hi trending shots. Hello. So again, moral of the story for commutative property, for whole numbers ho ya integers ho ya rational numbers ho, they only work for addition and multiplication. Subtraction and division are like these bad students. They do not follow any rules here in commutative property. So whole numbers ho ya integers ho ya rational numbers ho, they are commutative under addition and multiplication. All right, awesome. Now what about associative property? I always say that associative property is like an extension to commutative. Commutative where you only have two numbers, but in associative you can have more than two numbers. So I have taken my A to be minus 2 by 3, B to be 3 by 5, and C to be minus 5 by 6. What did I do? I first added my B and C, and then I added A to it. I got minus 9 by 10. I added my A and B first and then added my C to it. As you can see, I still got the answer as minus 9 by 10. So if I give you 3 or more rational numbers, the order in which you add them actually does not matter. The answer is going to be the same. So addition is associative for rational numbers. Since commutative did not work for subtraction, it will not work for associative also. Because commutative mein we took 2 numbers. Associative mein we are taking 3 numbers. Why will it work? It will not work. Hai na? So subtraction is also not associative for rational numbers. The order in which you subtract actually matters here. And then multiplication, it's a thumbs up again. Commutative works, so associative also will work because it's just an extension here. So I am taking 3 rational numbers, minus 7 by 3, B is 5 by 4, and C is 2 by 9. I multiplied my B and C first and then multiplied my A. I multiplied A and B first and then multiplied my C. The answer is the same. So, multiplication is associative for rational numbers. Again, division is a thumbs down. Subtraction and division are these two bad students who do not follow any rules of mathematics. So again, moral of the story here is, as you can see, for addition of integers, whole numbers and rational numbers, associative works. Multiplication also it works. But for subtraction and division, they do not work. Same as commutative property. Both of them do not work for subtraction and division of whole numbers, integers and also rational numbers. Guys, if you have any doubts, do let me know in the comment section. I will definitely reply back to each and every comment of yours. Alright, now let's talk about distributive property. What is distributive property? It is multiplication over addition. So as you can see, I have to write a C here. Alright, so what is this? Multiplication over 5 by 6 respectively. So here I have taken the left hand side. A multiplied with B plus C. So what did I do here? I first solved whatever is inside the bracket and then I multiplied the answer with A. That is my left hand side. First solve whatever is inside the bracket. Whatever answer I am getting, I am multiplying it with A. Now on the right hand side, what am I doing? I am multiplying my A and B plus A and C. And whatever answer I am getting, I am adding them. And I am getting 1 by 8. In both the cases, the answers are the same. That's what is your distributive property, which is multiplication over addition. So, A multiplied with B plus C is equal to A multiplied with B plus A multiplied with C. Now, my question to you guys is, does it work for subtraction, yes or no? Do let me know in the comment section or in the live chat. Do let me know. Does it work for subtraction? Can I say distributivity of multiplication over subtraction? Exactly. Yes. Distributivity of multiplication over subtraction also exists. So here A multiplied with B minus C is A multiplied with B minus A multiplied with C. There's only a difference of this minus sign here. That's it. Okay. A multiplied with B plus C is A multiplied with B plus A multiplied with C. है ना? This is multiplication over addition. Now this one is multiplication over subtraction. A multiplied with B minus A multiplied with C. Awesome, awesome. Very good, Shiv Kumar, and trending. So yes, it is applicable for subtraction also. All right. Let us solve a quick question here. Now, you have to solve this using distributive property. Good evening, Shiv Kumar. Now you can see it is of the form A multiplied with B plus A multiplied with C, which I can write as A multiplied with B plus C. That's what I'm going to do. I'll write it as 7 by 5 multiplied with minus 3 by 12 plus 5 by 12. So first I'm going to solve whatever is there inside the bracket here. So 7 by 5 and here minus 3 plus 5 by 12. So 7 by 5 multiplied with 2 by 12. Now what will we do? How do we multiply our rational numbers? Multiply the numerator with the numerator and denominator with the denominator. But I can see that I can cancel out things here. 2 into 1, 2 into 6. And then write it down in this simplest form. 7 into 1 will give you 7. 6 multiplied with 5 will give you 30. So what is the answer? 7 by 30. Alright. Achha, you're Shivani Kumari. Okay. Alright. 7 by 30. Yes, Kritishna, you are right. So Kritishna, Shivani and whoever was watching this video, do share this video with at least one friend of yours. So we have come to an end of the first chapter, which is rational numbers, and we are going to start off with linear equations in one variable, where I am going to introduce you to what is linear equation in one variable, and how do we solve them in the next class. Okay? So share this video with your friend, at least one friend of yours. Ask them to like this video and subscribe to the channel. And if you haven't subscribed to the channel yet, there's one subscribe button under this video. Click on that, because this channel is one-stop solution for all your math related problems. Alright, so thank you so much, guys. You people were lovely today. I'm going to see you very soon. There are a lot of exciting videos coming up over this weekend, so keep following our YouTube channel. Keep checking. There's some of the other videos coming up, very informative videos, very unique videos, I should say. So stay tuned, keep smiling. I'm going to see you soon. Bye-bye.